Good morning. We're going to take a look at the layers of the earth in your plate tectonics. So we don't have too terribly much after this, like I said, because there's just not a lot that we're going to be doing with this particular portion. So we're going to talk a little bit about the composition of the earth, though. So I don't know if we've ever talked about it, but what geology is it's actually the study of the earth. It's the study of what the earth's composition, study of the processes that occur on the earth, and then obviously geologists are the people that are the people who do the studying of the different processes. So you can have very specific geologists, like volcanologists are going to study volcanoes, obviously, and then you've got meteorologists would study atmosphere and the weather patterns and things like that. So this is a diagram of the earth if you were to take it and then kind of cut it open a little bit so you could see what it's made of. So the atmosphere, I don't know how well you can see this, but the atmosphere is actually this hazy part right around the outside of the earth there. That's going to be the air and the water vapor and all the stuff that circulates up in our air. So then we have the crust, which you can barely see. There's a darker line that kind of goes around the outside. So the crust is right there, and then you have the mantle, which is this orange part. Then you have your inner core, which is this red portion, and then the inner core, is that orangey ball right in the center. So we're going to kind of look at all of these minus the atmosphere. We're going to look more at the stuff inside of the earth, but that kind of gives you a visual. So the other part that we couldn't really diagram on that was the hydrosphere. The hydrosphere is anything on earth that's made up of the water, the surface water, so lakes, oceans, rivers, things like that, anything to do with the water. So the hydrosphere is important since it does carry the water, and water is necessary for a lot of things here on Earth. It dissolves things, so it serves as that solvent. It serves as a reactant in chemical equations. Living things require water for those chemical reactions that occur inside of those organisms. It helps capture heat. So it's a very important characteristic of planet Earth in terms of what allows us to support life. Water is going to make up about 70% of the Earth's surface. So most of the surface of the Earth is water. So of that water, of that 70%, 97% of that 70% is salt water. And then only 3% of our water here on Earth is fresh water. So most of it's in the oceans. So, and then from that fresh water, less than 1% of the water is usable for human use. So even though we've got all this water here on Earth, we really can't use much of it. So, okay. The atmosphere is going to be made up of, like I said, gases, water vapor, small particles like pollen, dust, things of that nature that are always circulating in the atmosphere. And so they form what's called convection currents, which will be important here in just a moment when we talk about the mantle, because we'll see convection currents again. So this is going to be really similar to a convection oven. So I'm sure you're familiar with the fact that warm air or warm objects rise. So warm water, warm air will always rise because the molecules that make up the water or the air when it's warm are spaced further apart. So there's fewer molecules and more space in a particular area. However, normally as these hot things rise, because they're lighter than the surrounding air or water, eventually they get cooler. And then when they get cooler, those molecules become closer together, and so therefore they become more dense. So the air mass or the water mass becomes more dense, and then it sinks because it's heavier. So because it's heavier, it's going to fall back down. That process is going to, I don't know if you can see my mouse, it's going to constantly form this cycle or this convection current. Okay, so with the atmosphere, warm air will rise, and then as it gets further up in the atmosphere, it's going to get cooler, just because the further away from the surface of the earth, the cooler it gets. And then that air is going to condense, become heavy, and then fall back down. But then as it gets closer to the surface of the earth, it's going to heat back up because of the sun's rays and our ozone layer and all of that. And so we're able to, that air then would then become warm again and rise. So that's how the air gets circulated. Okay? The importance of our atmosphere is that it's going to help with precipitation, so rain, snow, sleet, hail, all that fun stuff. It's going to reflect light, and it's also going to filter the sunlight. So it's going to filter some of it. It's not going to filter all of it. You're still going to get some ultraviolet light reaching planet Earth, which is how you're able to tan in the summer, if you can tan. And but it does filter out a significant portion of it. And then the other thing it's going to do is our ozone layer is going to help trap heat here on planet Earth. Think of it like a car on a hot day or a greenhouse. Most of the car is surrounded, at least the top part is glass through the windows. Same with the greenhouse. It's almost all glass. Some metal supports, but mostly glass. So light is allowed in, but light is then not allowed back out. It stays in the car. It stays in the greenhouse, which is why on a very hot day, sometimes you walk into you open your car and you get in, and it's hotter inside the car than it is outside the car, and that's because all of the heat has been trapped inside that car, or it's trapped inside of the greenhouse. And so that's the same idea with our atmosphere. It's acting like that greenhouse glass or the car glass. It's going to trap the heat from the sun, and then it's going to heat up the surface of the earth. Now, in addition to that, a lot of the things that we do here on Earth emit what we call greenhouse gases that are going to attribute to that greenhouse effect, that overall heating up of the earth. That's the greenhouse effect. And so things like our cars, certain things that are expelled into the air from factories will go into the atmosphere, and some of our appliances will give off fumes, and these things collect in the atmosphere and make a thicker atmosphere, or thicker ozone area, or thicker, not, I guess it's not ozone, it's a thicker layer in our atmosphere that's going to trap the heat more efficiently. So this is where the theory of global warming comes into play. So this is why people are trying to cut down on carbon emissions. Carbon is huge on trapping heat and light from the sun. So it does it very, very efficiently. So if we're putting more carbon emissions into the atmosphere through carbon monoxide, carbon dioxide, things like that, methane, which is CH3, I think, CH3 or CH4. So all carbon-based molecules, they're going to form that protective layer in our atmosphere that's going to trap the heat, which normally you think is a good thing, but if you have too much of it there, it's going to trap more heat, and not a lot of heat's going to be released back into the atmosphere. And so it's going to get hotter and hotter here on Earth, which is why people are talking about global warming. The idea that the Earth is getting hotter and hotter because we're emitting all of these greenhouse gases that are trapping that heat as a planet, our overall average temperatures are a little bit warmer. And so that's the fear with global warming. So, okay, so on to the geosphere. The geosphere is the core. We're going to start from the inside. We're going to start with the core. We're going to start specifically with the inner core and the outer core. The inner core is going to be solid metal, so nickel and iron, and the outer core is going to be liquid metal. So they're made of the same thing, but the inner core is going to be solid, the outer core will be liquid. Now, what's funny is the inner core is also hotter than the outer core, and normally the hotter you get, the more likely you are to evaporate and become a gas. So some people often ask, well, why is the outer core liquid and the inner core gas? Wouldn't the inner core, if it's that hot, wouldn't it become a gas? And normally you would be correct. However, since it's in the center, you have all of the pressure from the layers above pressing down on this inner core. And because of that, it forces the molecules into the solid state. Because gas molecules move around very freely, they're spread apart. But your pressure from your outer core, your mantle, and your crust in the hydrosphere is all going to be pressing down, and all that pressure is going to force those what would be gas molecules past the liquid and into the solid stage. So now the other thing is that the heat from that inner core is going to then contribute and allow, it's going to be cooler, but it's going to allow the outer core to stay liquid and not be solid. And then the fact that it's more liquid-like is what allows, it also helps the mantle to move, which will be important for your plate tectonics. So okay. I think this will be the last one just because I'm not sure how long this is going to take you since today is a shortened schedule, so we'll finish this later on Monday. So this will be the last one for today. Your geosphere, or sorry, your next layer out is going to be the mantle, and that's going to make up about 80% of the Earth's total volume. So it's the thickest layer by far. And it's made up of magma, which is basically melted rock. So the difference between magma and lava, if you did not know, is magma is located below ground. And then once it comes above ground, it's called lava. So volcanoes don't erupt magma, they erupt lava. It's the only difference. So just like up in the atmosphere, they had convection currents. The mantle also has convection currents. You have melted rock and you've got a very warm outer core below the mantle. So that would be like the Earth's surface. And then in comparison, the crust is going to be cooler than the outer core. So hot rock, hotter melted rock is going to rise. It's going to be less dense. So it's going to rise towards the crust. But then it's going to get further away from the core. So then it's going to get more condensed. It's going to cool down. And then it's going to sink. Then as it sinks, it's going to be going back towards the core, and then it's going to heat back up. And so that's going to be that convection current again. So you see convection currents in the atmosphere and you see them in the mantle. Now the reason why is why this is important is this is what allows for the plate tectonics to move. Specifically, your mantle is broken into 3 different parts: the upper mantle, your middle mantle, which is also called the asthenosphere, ASTHENOSPHERE. So asthenosphere, ASTHENOSPHERE, asthenosphere. So that's that middle mantle that actually does the convection currents. Your top part of your mantle doesn't usually take part in that. So this kind of we'll kind of get to a stopping point here. So on Monday we'll finish up and yeah. So and I'm kind of excited about it because when we start talking about some of the plate tectonics and things, I've kind of looked up some stuff about Italy for you. So you'll learn about the U.S., but you'll also I'll try to give you a little bit of information that you might learn about if you were taking this back in Italy. So at least hopefully it'll be a little more applicable for you. So, but anyway, if you have any questions, just let me know, and otherwise have a good weekend.